Okay, so first thing when we see this problem, we see the fraction exponent. So that means we're going to need a radical symbol. And then remember, the numerator goes inside, denominator goes outside. So we know this is going to be a square root. And then we're going to have this whole negative 144 inside the radical. And then it would have an exponent of a 1, which anything to the first power is just itself. So this is pretty much saying what's the square root of negative 144? Well, 12 times 12 is 144, and so is negative 12 times negative 12. So because we have this negative here inside, this is not a real number. Okay. Now this one almost looks the same as this one, except for it's missing parentheses. So those parentheses are very powerful. Since there's no parentheses here, this 1/2 is only going to the 144. So inside this radical, we have the 144, and then this negative just gets brought down here. So we have inside, out. So the index here would be a 2, and then anything to the first power is just itself. So then we have the square root of 144, which is 12, and then we bring down the negative. So we get negative 12 as our answer. Okay, so here we see the fraction as the exponent, so we put our radical, and then we would know the outside, the index here is a 5, and then we'd have 32x to the 10th in the inside, and then the exponent inside here is a 1, so we would raise this to the first power, but that won't do anything because anything to the first is itself. So this is what we have here. So the fifth root of 32, what times itself 5 times is 32? That would be 2. So 2. And then remember from section 8.1 that the rule here, the quick way to do it is to see how many times 5 goes into 10, which is twice. So we would have x squared. Now another way to think of it, as we have 10 x's, this is why we learn those rules, because this would take longer. And then our index is a 5. And that's how we know the exponent here is a 2. Because x squared multiplied 5 times would get us x to the 10th. Okay, so now I'm going to do this problem again and show you a different way you could have done it. So this works. You see the fraction exponent, you immediately put a radical and set it up. So another way we could have done this is by distributing the exponent. So then we'd have 32 to the 1/5 power, and we'd have x to the 10th, and then our rule is to multiply. So we'd have 10 times 1/5. So again, this 32 doesn't have an exponent, so it's like a 1. So 1 times 1/5 is just 1/5. So 32 to the 1/5, I'm going to wait to do that in a moment. But here, 10 times 1/5 is 2. So we get x squared. And then 32 to the 1/5 says this. So inside, out. And then what times itself 5 times is 32 is 2. So we would get 2x squared also. So again, we could have set this up immediately as a radical, like this, and simplified it to this, or you could have distributed the exponent, and we still get 2x squared. All right, let's take a look at this one here. So again, 2 different ways we could do this. The first way we do it is we see that fractional exponent, so we immediately put a radical symbol, and then inside, out. So the index on the outside here is a 3, And then in the inside, we'd have 1/8 squared. We could also do it this way, where we do the squaring after. So this exponent here can be done after, or it could be done first. So if we do it first, then we'd have 1/8 times 1/8, because that's what this is saying, which is 1/64. And then what times itself 3 times is 1/64? That would be 1/4. Okay. Now the other way is to do the square after. So we would do what times itself 3 times is 1/8. So we do this first. And that would be 1/2 times 1/2 times 1/2. Then we bring down the square, and 1/2 squared, 1/2 times 1/2, right, is 1/4. So we get the same thing that we got here. So either way. Now, another way we could have done this is by distributing this exponent. So we'd have 1 to the 2/3, and then 8 to the 2/3. And then we could have wrote this like this, so converted it to the radical after. And again, remember the numerator exponent can go inside, so I can go here and then it would make it 64, or I could do it after. So then up here, this is saying what times itself 3 times is 1 squared, so that'd be 1. And then down here, this is saying what times itself 3 times is 8, so that would be 2, and then the squared, and you would get 1/4. So 3 different ways to approach this problem, and it still comes out to be 1/4. All right, let's take a look at this one here. So immediately we see a fraction, and now after today's class, you now know whenever you see a fraction as an exponent, put one of those radical symbols, and then inside out. So the outside represents the index right here, and then we'd have the x minus 3 inside, and the inside exponent here is a 5. Okay. Then, to simplify this, we see how many times 6 goes in a 5. And it can't go in a 5, so then this would just be our answer. Now, something else I wanted to talk about. So I'm going to bring this up because this has a minus right here, so these are stuck together. So even if it was something different than x minus 3 to the 5th, I wanted to compare these two here and talk about what the difference is here. So this one has a plus sign right here, whereas this one has a multiplication. So when there's a plus sign, you cannot, do 2 goes into 2 and the square root of 4. These cannot be broken up. So you cannot, this problem right here, that's it. You can't do anything to that problem there. But when there's a times sign, when it's just a monomial like 4x squared, then this you can do as the square root of 4 is 2, and then 2 goes into 2 one time. And this would equal 2x. So let's talk about y real quick. So inside the radical here, so that I can understand why this works, I use something that I know. So regular old numbers. Actually, let me use this. Let's do that example. That'll be easier for you guys to understand. So the reason why we can't do square root of 16 plus square root of 9 and get 4 plus 3, which is 7, is because if you do the inside of the parentheses first, 16 plus 9 is 25. So the correct answer to this, the square root of 25, is 5. And you see that it doesn't match. So that's how I know when there's a plus sign in between that you can't separate these two. No, we can't do that. So when they're a plus sign, they are together. So when they are together, if this exponent here, which is a 2, doesn't go into this, there's nothing else you can do. So if we go back to this problem right here where I said there's nothing we can do, this is the final answer, we cannot, because of this minus, we can't split this problem up. So let's just pretend for a second the problem was like this. So if there's a 2 here, even though 2 goes into 2, we can't split this up here. Even though the square root of 9 is 3, you can't do that. But if the problem looked like this, then you could do the square root of 9 is 3, and 2 into 2 is 1. So if you think about why you can't do this, so if you had done 2 into 2 is 1, and then the square root of 9 is 3, this doesn't work because this symbol here is saying what times itself gets you this. So if you did x plus 3, well, x plus 3 times x plus 3 would not get you the x squared plus 9. So that is why you can't, when there's a minus or plus, you can't separate these two here. The only thing you can do is see if the index goes into the exponent out here.